So good morning, everyone, and welcome to this course, Design and Detailing of Foundation Systems, that we are going to start from today. This is the session 1. And to begin with, I and Akanksha are very thankful to all of you for joining this course. So I hope my voice is audible to all of you, and you can see me also, and you can see the presentation as well. So whatever you have to write, I mean, if you want to communicate, you will have to write it in the chat box because all of you are on mute. So you would not be able to unmute yourself. So whatever you have to write, the only way to communicate is to write it in the chat box. So I hope I am audible. You can see my video also, and you can see this presentation as well. So yes, so I was saying that it is good to have all of you join this course. We are having a very good mix, as we always do, of practicing consultants, undergraduate, postgraduate students, people from the academia, and working professionals. So it is a good group that we are having. Many of you have chosen to take this course as self-paced learning. That means you will be attending sessions as and when you get time on the portal. Towards the end of today's session, I will also tell you how to access the portal. So let us begin then. We will start with our session 1 of the course today. So I have just made a small presentation because I wanted to tell you a few points. So design and detailing of foundation systems. What are we going to discuss today? Mainly, we are going to start the course with the first topic, that was the geotechnical investigation and its importance for structural engineers. See, we are not geotechnical engineers. Geotechnical engineering is a complex field and a vast field in itself. So here, our objective is not to become geotechnical engineers, but our objective is to basically understand a few things related to geotechnical engineering. Okay. Why we want to understand? Because generally as structural engineers, when we have to design footings, foundations, that is, when we have to design foundation systems, generally the input that is required for design of foundation systems is geotechnical reports. All right. So we should have some basic sense of the parameters that are given in geotechnical report, and we should be able to understand the basic concepts related to report. Okay, so first of all, we would be studying that. Again, I am saying we don't want to become geotechnical experts. If we become, it is well and good, but our primary intention over here is to use the report for our purpose. What is our purpose finally? Our purpose is to design the foundation systems. All right, structural design, that is. So first, we will see what is the importance of geotechnical investigations and studies. That is the first topic for today. So let us quickly go into it. All right. Right. So see, till now, if you see our general structure, any structure that you see, the general load paths would be general load path for your regular structures. So load first comes on slab. Whatever live load, let us say you are also sitting in your room or office, you are sitting on the slab right now, isn't it? So the first load transfer, takes place at your slab level. From slab, the load goes to beam. We all know this. From beam, the loads go to columns. From columns, finally, here in place of columns, and there can be shear walls also. Okay, there can be load bearing walls also, you know all these things. So from columns, then your load will then flow to foundation systems. Okay, and from foundation your load finally flows to where? What will be the last point in this sequence? So the last stage would be the load finally flows to earth. isn't it? So basically this foundation system is the interface. This acts as an interface between your load transfer from foundation to earth. So we can say that this is an interface. Okay. Now, why does it become important? Because till here, your loads were getting transferred mainly between all your RCC elements, or let us say steel elements, whatever your structure is. Here, the interface were intra-material, I would say, isn't it? Within concrete systems, these load were flowing. Or let us say you had a steel structural system, then within steel structural systems, your load were flowing. But here, for the first time, the load is going to get transferred to earth. So foundation is an interface between your load transfer. We generally therefore call these as your superstructure also. You will see that these, we call them as superstructure. Okay. And this foundation, we generally call it as substructure. All right. So this becomes extremely important because now the properties and the specification of this earth comes into picture. Okay. So now your foundation basically is going to depend on the characteristics and properties of your earth. By earth, I mean my subsoil or substrata. All right. To find out these properties, what is important? If we want to find out the characteristics and the specifications of this earth, when I'm saying earth, basically I mean the subsoil or substrata. Okay. So to find out these characteristics, we take help of our geotechnical study. So this becomes extremely important to find out the correct parameters. You should be doing a proper geotechnical study. Okay. So that itself explains the importance of this study. All right. If you have two structures, let us say these are similar structures. You had a ground plus 1 2 story structure. Okay. And then you have a different structure. I mean, same structure at a different place. So again, this is also ground plus 1 2 identical structures. All right. And let us assume that they were in same seismic and same wind zones. So for both of these structures, the wind zones and the seismic zones were also same. In this scenario, what do you think? Will the superstructure remain the same for both these structures? Can we provide the same superstructure? Yes or no? Let us say this is structure 1, this is structure 2. They are identical structures, identical ground plus 2 story structures in the similar wind and seismic zones. So what do you think? Will they have the same superstructure? So the answer definitely would be yes. The structures would be, I mean, your buildings would be having similar superstructures, isn't it? But uh, can you say with the same surety about the substructure for this? Can you say with surety that they will have the same substructure or same foundation system also? Can you say this? Yes, tell me. Can we say this with surety? So the answer would be no. We cannot guarantee that both these structures will be having the same foundation system also. All right. So even though they are identical buildings, they are in same wind and seismic zones, more or less they will be having the same superstructure. But you cannot say the same thing about the foundation systems. So these foundation systems may vary as per the subsoil strata. Okay. As per the subsoil characteristics. Okay. I hope you understand this. So therefore, this again becomes important. Your geotechnical investigations or geotechnical study becomes very important because at different locations, your soil strata or your soil characteristics may have a lot of differences. Okay. So we had done such kinds of projects. We have done these types of projects. So just to give you an example, we were doing a project when I and Akanksha used to work in our earlier office. So we had a project in the country of Saudi Arabia. We were working for a multinational company. So this was Saudi. This is Saudi Arabia. If you see, this is the map of, I mean, rough map of Saudi Arabia, not very accurate. So, and then you have got two neighboring countries over here. I think one is Yemen. This is Yemen, I think, if you see the map. And then this is Oman, isn't it? And then you have, I mean, this is not a very good map that I have drawn. Then you have Bahrain, and then you have UAE and all those things. So what we had to do was, uh, in the entire southern border of Saudi Arabia, okay, this is Saudi Arabia. In the entire southern border, they had to develop security infrastructure. So this is almost 2000 kilometers long border that Saudi Arabia shares with Yemen and Oman. So they had to develop, in a length of 2000-kilometer border, they had to develop security infrastructure at different locations. I think there were some 20 or 30 locations. All right. So the locations, they had identified 20 locations, let us say, along the border. All these locations were having exactly the same buildings. For example, this is location 1, site 1, and this is site 2. Both these sites will have same type of structures. One would be some office complex, then one would be officers quarters, then you would be having a water tank, you would be having a barracks and all those things. Okay. So I'm giving you a practical example of this thing that I just said. So your superstructures were all similar. Okay. But along this 2000-kilometer length, what was changing was the soil characteristics. So at some locations we just got sandy strata, at some locations we got hard rocks, etc. So our foundation systems we had to continuously change. So just to iterate this point, that your foundation systems may change from place to place depending on the subsoil characteristics. Therefore, it is important to carry out geotechnical studies. All right. So this brings to the next point that I have written over here. That the geotechnical investigation depends on soil properties. I mean, you need to correctly identify the soil properties at your site. Therefore, you need to carry out the geotechnical investigations, and these site properties vary. They sometimes vary within a site itself. I have seen such projects where what happens is that within a site, there is considerable differences in the geotechnical properties that you get. For example, if this is a plain surface, and let us say the hard strata rock is like this. Okay, the underlying hard strata has this type of a geological formation. So what I'm trying to say over here is that this is your ground level. Ground level seems to be fairly plain, but the underlying rocky strata has a slant geological formation. So what one would get over here, that at this location, at shallower heights or shallower depths rather, you will get hard strata. But let us say you had to construct something at this location, you would have to go dig deeper, isn't it? So these types of variations you can get even within one large site. So the soil properties vary. These variations cannot be predicted. You cannot have a formula to predict these variations unless you do some actual testing. So therefore, these geotechnical investigations become important. Of course, why do we need to further carry out the geotechnical studies? Because you have to have the adequate knowledge of soil properties. When I say soil properties, we mean both the mechanical properties, okay, mechanical properties, and also the physical properties. What do I mean by mechanical properties? I will tell you. And sometimes you also need to know the chemical properties. Okay. So adequate knowledge is required, and it is, of course, essential, I would say, whenever you are designing projects. So to get knowledge of the soil properties also, you need to do the geotechnical study. All right. What are the other reasons why you need to do geotechnical studies? I will try to give you some points which will further reiterate this point. Okay. So I will present you some real examples from our design experience that we have done in our offices, that these were the issues that we faced for some of the actual projects that we did, which will tell you or which will explain you that why geotechnical study is extremely important. So I will take a few examples over here. Let us try to discuss one by one. And all these are real examples. Uh, they are not fabricated. Okay, these were the real situations that we had faced in the past. So in one of the projects that we were doing, we were appointed as design consultants. The project was taken by some company uh, as a DBOT project. What do we mean by DBOT project? What do we mean by this DBOT project? Yes, tell me. What is the meaning of DBOT? Is anyone aware of it? Yes, so DBOT project means that the company which is chosen to do this project, they have to do all the things. So D means design, D means design, B means build, O means operate, and then transfer. All right. So the company, whichever company is chosen, they have to first design the project, they have to construct it, they have to operate it for a certain period of years, and then they finally transfer it to the uh, main agency. Generally, the agency is government in these cases. Okay. So these are called as DBOT projects. Some projects are only BOT projects. What do we mean by BOT? So design is not to be done. Only the agency has to build, operate, and transfer. All right. And some projects are DBOT. So they have to design, they have to build, they have to operate, they have to transfer also. All the road projects that you see these days, all the road projects that are given by NHAI, or even big, I would say big infrastructural projects, they are all tendered on this DBOT basis, isn't it? So the company has to run this project for some 25 to 30 years, and then they will finally transfer it to government agency. For example, even if you see solar plants being constructed these days, roads, bridges, even big agricultural projects, all these projects are DBOT projects. Okay. So uh, this was one such DBOT project that was being done for the Municipal Corporation of Indore. So Municipal Corporation of Indore was the client, and the company had won the tender for this DBOT project, and to do the design work, we were chosen. So what we were doing, we were just doing the design work for it. Okay. For the design work, we were chosen. I'm giving you some real examples. What are we discussing right now? I'm giving you some real examples to reiterate this point, that geotechnical investigations are extremely necessary. Okay. Or I would say are very important for your projects. So when we went on the site, what we saw was that when the geotechnical investigation was carried out, what we came to know, and to our surprise, even this agency which was given this project, they also came to know that, let us say this was the surface. Okay. This is your road level outside. This is your road level, let us say. When the geotechnical investigations were carried out, to everyone's surprise, what we came to know, that the actual surface on which we were standing, this was just filled up earth. Okay. This surface was actually just filled up earth, and there was a large garbage dump over here. This was the municipal land. So basically what they had done was that they had created large garbage dump. So all this was garbage dump. This was all garbage, trash. All right. Landfill, you can say. And the real ground level was over here. So this was the real ground level. So what might have been the case, that there would have been an original depression over here, and the municipal corporation or the municipal agencies just decided to fill this up with garbage as the landfill. So actually where we were standing, there was a 6 meter, 20 feet. There was a 6 meter garbage dump. All right. Now all their structures had to come up over here. All the structures that were planned, they had to come up over here with at ground levels, isn't it? Whatever structures were planned, let us say there was a big tank over here that they had to construct. There were some sheds that they had to construct. So all of them had to come up over here at road level. So now what happened, that because their actual ground level was 6 meters below, their entire design or their entire scheme had to be changed. Are you getting this point? So instead of a normal situation where they would have put their footings somewhere over here, what they had to do, they had to take now 6 meters like this. They had to take 6 meters column, and then from below ground level, then they had to go for their foundations. Are you getting this point? So what this led to, this led to large escalation in their estimated cost, isn't it? Because they were thinking, this agency which was carrying out the DBOT project, they were thinking that it would be a regular foundation, let us say some 2 meter or 2.5 meter below your ground level, they would be putting your footing. But to their shock and horror, this was a 6 meter landfill. So their entire budget went haywire, and then they had to revise all their calculations, and all the footings had to be provided at least 2 meters below the 6 meter level. So it looked so funny that we had to construct all these columns from this level. Okay, so their entire budget went out of the place, and actually they incurred losses on this project. Okay, so are you getting this point, what I'm trying to say over here? This was an actual project that was carried out by us. So what could have been the proper approach in such a case? What do you think would have been a much better approach? Yes, tell me. In such a case, what could have been a better approach in this project? So a better approach would have been that when this agency was going to bid for this project, before bidding, before finding out the estimate, what they should have done, they should have done the geotechnical investigations. Do we agree or not? They should have done the detailed geotechnical investigations. Okay, so what was the mistake? Their mistake was, because they bid without doing the proper geotechnical investigations, because of this they were left with a big surprise when they actually started their work, and everything just went out of the place. So because their initial estimates of budget did not include this thing, therefore this led to all problems. So whenever big projects are to be executed, and let us say as some agency you are going to bid for project, let us say you are going to do the BOT type of projects, you should always insist for geotechnical investigation reports first, isn't it? Because your entire substructure strategy will change according to that. Your entire substructure strategy changes depending on the investigation or depending on the subsoil characteristics. So you should always insist for proper geotechnical investigations. Do we get this? Is this clear, all of you? Hello. Yes, you can write yes, no, right. And these are actual problems that you face. And in many of the cases in infrastructural projects, this is a common problem that is seen, that because improper geotechnical investigations are carried out, or sometimes investigations are not carried out. This is true for road projects, railway lines, that we do, and detailed project reports or DPRs are made for such projects without carrying out proper investigations, and then we are left for surprises in the later stage of the project, and then it leads to cost escalations. Okay, so therefore this is very important to carry out proper investigations. So this was the first case that I wanted to tell you. What are we discussing? I will again repeat. We are discussing why geotechnical investigations and why proper geotechnical investigations are important. Okay. Okay. So this was the first case. Then the second case, again, I will tell you, it was related. So we were the design consultants in this project, but we were only, we only came in the association after the tender had taken place. So after the tender had taken place, once this agency decided to come to Indore and start the construction work, then they needed some designers. So that's how we came into picture. So we were not into picture before tendering. Otherwise, we would have surely suggested them to carry out the investigations before bidding. Anyway, the second case I will tell you was a hotel project in Indore again. We were not directly associated with this project. We sort of got indirectly associated at a later stage. I will tell you when. So this project was a hotel building in Indore. This building was going to be constructed in a large open space in one of the bypasses of Indore. So there is a bypass, Indore bypass road, that is Indore bypass road. So those some patches of that bypass are not heavily populated, large open spaces you can see over there. Okay, so the project was to construct a hotel building, a big hotel building, a multinational chain hotel building was going to be constructed over there. All right, the hotel building had a basement. I think 2 levels of basements they were going to construct. So let us say this is their ground level, and then they were going to, I think, construct 1 level or 2 levels of basements. Okay, basements for parking and basements for other utilities, and then they had some this. All right. So what happened was that when the construction was going on, they had constructed these basements, and I think they were on second or third or fourth floor. I don't know where they were actually. And what they experienced, that was the year when there was a very heavy rainfall in Indore. Okay, around I think Indore's average rainfall is around 40 inches. 40 inches is the average rainfall we get in our monsoon. I mean, throughout the year, this is the rainfall that we get. So in that particular year, I think the rainfall was around 55 inches that had taken place. And their construction work of this hotel building was, I think, at first or second. I don't know the exact floor where they were. And suddenly what happened, that these basements just cracked. This entire basement slab just got punctured, actually punctured. This slab was actually punctured. It was displaced. Okay, there was a huge fissure in your basement slab, and this entire basement slab was just filled with water. So what had happened, that this entire basement slab got filled with water. Okay, and there was an actual puncture in your basement slab. So what has happened was, what had happened, so then we see, when this thing happened, then we were basically called as experts to investigate what actually is the problem. So the problem was very clear. I think you can tell me what was the problem. Yes, what do you think was the problem? So Zoom user is saying uplift. Correct. So what was the problem? That this basement raft or this basement slab that was over here, this basically gave way. Why did it give way, or why did it fail? So this failed because of the heavy uplift pressure that was acting on these basement slab level. Okay. And because this basement slab was not properly designed for this uplift or for this swelling pressure, I would say, what happened, that this just gave way. And once it gives way, then this water just percolated and it filled up your entire basement level. Proper geotechnical investigations were carried out for this project. I will tell you, because this was a big project, proper geotechnical investigations were carried out. But what do you think would be the problem in what do you think would have been the problem? In this case, investigations were properly carried out. Okay. In the last case that we took, there were no investigations that were carried out before tendering. Okay. Now, in this case that we are discussing, there is a different sort of a problem. Investigations were carried out, but what they had failed to measure, in this case was the ground water table. What do you mean by groundwater table? So groundwater table means that your soil is saturated by groundwater till a certain depth. Okay. So for example, oh, Mr. Zoom user is Ishan. Very good. You can, all of you should log in with your full correct name. Okay. That's how we can identify you. So today we are allowing, otherwise from tomorrow we will not allow. I mean, then it becomes difficult for us to identify, isn't it? So it is a request to everyone to log in with your full name. Full name as you have given to us. Yes. Anyway, so there is a thing that is called as groundwater table. What is meaning of groundwater table? That your soil is saturated generally with water. Okay. So your pores, you know that soil comprises of particles. So these are soil particles, and these soil particles are filled with water. So if these get filled with water, this is called as a saturated condition. There is a technical name for these kinds. I think it is called as the unconfined aquifer. I don't know the technical name, but this is the groundwater table. So let us say if this is 2 meters, so this will mean that from your ground level, this is your ground level. Okay. Now below your ground level, 2 meter below is the groundwater table. This is the meaning. Now what happens that if you are going to construct anything in this region, and let us say this structure, I'm just giving you some example over here. This structure is 3 meters below your ground level, and your groundwater table was 2 meters below the ground level. So how much depth of water is your structure displacing? Yes, tell me, how much depth of water is your structure displacing? So basically I would say very easy. My structure is displacing 1 meter depth of water. Are you getting this? My structure is displacing 1 meter depth of water, isn't it? So because of this displacement, because my structure is taking place of water, my structure is displacing 1 meter depth of water, my structure will experience an uplift pressure or buoyancy pressure equal to 1 meter height of water. Are we clear with this? Do we understand this concept? Yes, no? Hello? Okay. So this is called as the uplift pressure. This is called as the uplift pressure. Now, if your groundwater table was like this, for example, if your groundwater table was here, let us say your groundwater table was here, and as per your reports, you got that your groundwater table was 4 meters below ground level, and your structure was going only till 3 meters below ground level. In this case, will your structure experience any sort of uplift pressure in this case? Yes, tell me. In such case, if your groundwater table is 4 meters below ground level, your structure was going only till 3 meters below ground level. In this case, will your structure experience any sort of uplift? So the answer would be no, because my level is over here. My level is over here only, isn't it? Is this clear, everyone? I hope we are clear with this. All right. So now what they had done was, yeah, just a related thing over here. You must have heard about the story in Mahabharat, that when during the war of Mahabharat, I think Bhishma Pitama was hit by Arjun's arrow, and then basically Arjun went there and asked Bhishma Pitama what he wanted. So Bhishma Pitama said that he was very thirsty. If you must have heard this story, isn't it? He said that he was very thirsty, and so Arjun, it is said that he just shot an arrow in the ground, and there was a water fountain that came up, isn't it? There was a water fountain that came up, and then that is how Bhishma Pitama quenched his thirst. So if you see in those regions of India, if you see the regions between Ganga and Yamuna, the entire northern plains, I would say from Punjab till Bengal, the groundwater table is at a very, very high level. Okay, so it is very close to ground because of the proximity of two big rivers. So it is very much possible. I have seen with my own eyes that if you dig even a small hole in those regions, very quickly that hole gets filled up with water. Why? Because groundwater table is very high over there. Anyway, so that was just a related story. You can relate it by the actual things that you see in those regions. Now, what they had done in this case was, in this project, what they had done, that they had carried out the report, geotechnical investigations they had done, but they had done the geotechnical investigation in the month of May. Okay, so the geotechnical investigation was carried out in the month of May, and then what they had written in their report, that the investigation was done, and then they found that the groundwater table was, let us say, over here. All right, let us say, I do not remember the exact values. I'm just writing some value over here. So they reported that the groundwater table was checked, and the groundwater table was found 8 meters below the ground level. Okay, and then your structure was only going to be constructed till, let us say, 7 meter below the ground level, or 6 meter below the ground level, let us say. So they concluded that there is no need for uplift pressure to be. So the report did not conclude anything. They just said that the groundwater table was 8 meters below the ground level. So the designer, probably what the designer did is that because groundwater table was 8 meter below the ground level, our structure was only going to be constructed till 6 meter of depth. The designer chose not to design your basement slabs for uplift. All right. So there was no uplift pressure that was considered, or that was taken into account for these rafts. Now what happened in rainy season, because this was done in May. In May, we know that in India, month of May is the month of extreme and intense heat, extreme summer, isn't it? So what happens in these summer months, your naturally water table will go down. Your rains have ended in August, September. The previous year, let us say, your rains have ended in August, September. So from August, September till May, right through the winters and right through the extreme summer, naturally your groundwater table will go down. Okay. So what happened that in the rainy season, because of intense rains, and as I told you, that year was the year of heavy rainfall in Indore. So what happened that your groundwater table rose up. So groundwater tables rise. Okay. In rainy seasons, you get groundwater table nearer to ground. In summer seasons, you can see that your groundwater table go below. So what happened, that the groundwater table rose up because this was a large open space. So there were a lot of possibilities of water percolating, and because that year we had got intense rainfall, so your groundwater table rose up, and these basement slabs were not adequately designed for groundwater or for uplift pressures, and therefore they gave way. Okay, so is this clear what happened? Yes, is this clear to all of you? Hello. Yes, no. Okay, so what was the problem over here, and what could have been a possible correct way that could have been adopted? So the problem was that the groundwater table was measured, but it was measured in the summer months when we know that the groundwater table would be at the lowest levels possible, isn't it? So what should have been done was that either this groundwater table measurements should have been done in the month of post monsoon, just after monsoon maybe, or there should have been adequate safety margin that should have been considered. So what is this is the same thing that Prasad sir is writing. He is saying that groundwater table rises in monsoon period, and therefore we should consider some safety margins. So this is the exact suggestion that I would also have. Generally, all your reports would indicate that what was the period during which this testing was carried out. All right. So therefore, it is extremely important as a designer that you should understand uh, the seasonal variations possible. Okay. So yes, James is asking, so groundwater table depends on season as well. Yes, it depends on season. The groundwater table rises and falls as per the seasonal season. Okay, so there is a seasonal variation that you get. Now there is an added problem that you have in Indore. In Indore, we have a black cotton soil. What do we have? We have a black cotton soil. Black cotton soil is a very sticky type of soil which expands when it is moist. Okay, there is a large swelling that you get in black cotton soil when it is moist, and there is a large amount of shrinkage that you get when the soil is dry. So if you happen to visit any fields, I do not know if you have visited any fields. Field means farm. If you have visited any farm where you have black cotton soil, you will always see very large cracks over there. Okay, you see large deep cracks in the months of summer. If you go, these cracks can be as deep as 600 to 800 mm. Okay, so black cotton soil has this problem that it swells under moisture. It has a large swelling potential. What is meaning of swelling? Swelling means that if dry black cotton soil was having a volume of 1 meter cube, the same wet black cotton soil can swell as much as 2 meter cube, just double. There's a large swelling that you get. Okay, and when it is dry, it can shrink to very, very small volumes. So in black cotton soil, this is a known problem. Now in Indore region, we have black cotton soil till considerable depths. We have black cotton soil till 2.5 meter depth generally. Okay, because Indore is in the Deccan Plateau region, which has been formed by volcanic eruptions. So all these are black cotton soil regions of India. Okay, so in these black cotton soil regions, even a fresh graduate in Indore knows that black cotton soil is a problem for footings. Black cotton soil is a problem for rafts. Okay, so we always, as structural engineers in Indore, whether there is groundwater table present or not, we will always design our rafts and we always design our basement slabs, basement walls for these uplift and swelling pressures. Okay, as we say कि Indore का बच्चा बच्चा जानता है this thing, isn't it? Everyone in Indore knows this. Every structural engineer worth his or her soil knows that there is a problem of black cotton soil in Indore, and there has to be adequate design consideration for these swelling pressures. Now, what has happened was that these structural designers were from Mumbai, I think. So they were unaware of these issues, and they just look at the report of groundwater table. That groundwater table was carried out, testing was done in the month of May. So they were unaware of all these issues, and they designed their basement slab and raft without considering uplifts and without considering any buoyancy, and that was the problem. Okay. So in Indore, we design for uplift and we also investigate the swelling pressures. All right. So if you would have asked me, if you had asked me what to do in such cases, I would have not relied on any groundwater table report. And as a safety margin, I would have considered, yes, what Prasad sir is also saying, we consider that groundwater table as a worst case will rise, let us say, till 1 meter or 1.5 meter below ground level. And we would have designed our basement slabs and routes for this pressure. We would not have relied on groundwater table report. Okay. Because we in Indore know these problems. Understood? So this is what we would have done. Anyway, so is this clear? This second case? Is this second case clear? Yes, no? Yes, okay. Now I will give you a third case. So again, what would have been, yes, remedial measure, very interesting. What was the remedial measure that was considered in this project? Now what had happened, your raft had given way, isn't it? Your raft had given way. So basically that monsoon season, you could not do much. Now afterwards, they had two choices. What were those two choices? That this raft should be replaced with a load bearing raft, which could take the uplift pressures. And you needed to redesign these walls also. So finally, their budget that would have been involved in this repairs was too large. They decided that this was too large a budget to incorporate. So then what they did, not a very good solution as such, but these people, what they decided, to just fill this basement up with soil. Okay, so finally they did away with those basements and they just filled up all these basement levels, and their structure was only then ground up. So they did away with their basements, and the front landscape portion that they were going to develop, that they converted it into parking, which was initially planned in the basement level. So that is what they did, because they did not have much budget with them. Okay, they did not have much amount to go for the remedial measures. So unfortunately, they just decided to fill this entire thing up with soil. They did away with the basements. Okay. Yes. But if they had adequate budget, what they could have done was to strengthen the raft. So they should have, we have done such kind of projects where there were failures due to uplift, and then we retrofitted the rafts and we redesigned and re-provided the raft and made it capable to take the uplift pressures. So that could have been done, but because of budget problems, they decided to just do away with all these things. All right, they just decided to delete the basements. Anyway, not a very good solution, but that is what they did. Are we clear? Interesting, isn't it? So what I wanted to tell you, right, in this, so then in this first case, geotechnical investigation was not carried at all. It was not done. In this second case, investigations were carried out, but the data collection was done at an inappropriate time. Okay, and because of lack of understanding of local conditions, this led to the issues for this particular project. Now I will give you a third project, which is actually reverse of what we discussed in second project. Okay, so what we discussed in second project, now this third project that I'm going to give you, again, this is an actual case. that happened. So this third case is a diametric opposite case to the case 2 that we discussed. So here in second case, how were we involved? We were not involved directly. We were just asked to come up as experts when this failure had already taken place. Okay, so we basically gave them these suggestions to strengthen the raft. We prepared, or we tried to prepare a design scheme also, but then finally that was not approved, as I told you, because of the budget considerations, and they just filled up the raft. So we came into the picture in this second project after failure, post failure. Anyway, in this third project, we were associated as design reviewers or peer reviewers, what you say. Okay, design reviewers, reviewers, REVIEW, reviewer. Yes. So this was a solar project. This was a utility scale solar power plant. I think this was a 5 megawatt project. So what happens is that there is a large open space. You can say around, I think how much? Large space, large open space. And there what do you do is you assemble solar panels. I think you must have seen solar plants, ground mounted solar plants. So what do they do is that they will assemble solar panels like this. Okay, these solar panels will be supported on some frames, and they would have a large array of these panels. And then whatever electricity is generated by these panels, it is then transferred to the electrical grid. So that is how this becomes a generating station. Okay, so this was, I think, a 5 megawatt project, 5 megawatt project that we were associated as reviewers. So in these projects, what happens is that people, to save cost or to cut costs, what is done is that we go for pilings generally, and those pilings are very short piles. Typically those piles would be around 1.5 meter depth. Okay, so 1.5 meter depth, single pile for one column. This is, let us say, one column. For one column you will have a single pile, 1.5 meter depth. So these are called as short piles. Unfortunately, I will discuss these issues in detail later on, but unfortunately our Indian codes still do not consider or still do not have adequate provisions for these short kind of piles. Okay, so the Indian standards, that is the IS 2911 series, which is the which are the Indian codes for piles, these still do not have the adequate provisions for short piles. Anyway, now for this piling, what is the sequence of events? I will first explain you, then it will be easier for you to understand the problem. In these piles, where there are large number of piles involved, let us say in this project, if I remember correctly, there were 6,000 piles that needed to be done. Okay, 6,000 piles needed to be done for this project. Now in piling, what they do is that they first, this was a clayey type of a soil, just like similar to the black cotton soil that you get in Indore. Now what do they do in piles is that first they will do some field test. I will be explaining you these things in coming sessions. So they will do some field test. They will take the sample. Okay. Once they take the sample, they will find out certain physical or mechanical properties of soil. Typically those properties are CN5 values. So they find out CN5 values. And then on the basis of these CN5 values, they will be calculating a tentative pile capacity. There are some formulae which are called as static formulae. I will tell you more about this in the coming sessions. So they will calculate some pile capacity. All right, what they have done, I will repeat. They do some field test. They will collect the samples. They will take it to the laboratory. In the laboratory, they will do certain testing. they will find out certain soil parameters, and then on the basis of some static formulae, they will find out the pile capacity. Okay, so this pile capacity is actually a theoretical capacity that they have got. This is not the actual capacity, remember. This is theoretical capacity that they have worked out. Okay, then what they do is, once these theoretical capacities are worked out, then they will go to field, they will cast an actual pile, we will call it as the test pile. So they will cast an actual test pile, and then they will test it, and then they will get some pile capacity from field. So this we can call it as the field pile capacity. Okay, and then they will compare these two values. Which two values? One was the value that you got theoretical pile capacity, which you got from some static formula. Okay, this they will compare it with the field pile capacity value. Is the process clear? Yes. Is this process clear to all of you? Hello. This is the general process that is adopted. All right. Mr. Syed is asking type and length of pile. Later. That will come later. Just try to understand the involved issue right now. Okay. All right. So this is the usual. This is the usual, I would say, process that is adopted. Now, what they did was, interestingly, see, this is going to be the exact opposite of what I discussed in the second case. Now, here the field tests were carried out. Yeah. So the field tests were carried out, and then, so this is called as the initial testing. What do we call this as? Initial test. So field tests were carried out. The sample was taken. The C5 values were measured. These capacities were calculated, and this initial test was done. Now these testings were done in the month of monsoon. So this testing was done in the month of monsoon. All right. Now in the month of monsoon, please try to understand that your water table is high. As I just explained, post monsoon, I think this was done in month of September or October, just after monsoon. So after monsoon, what happens? Your water table is high. So because your water table is high, these clayey types of soil, what they turn into very sticky type of soils. All right, try to understand. These clayey soils, they become very sticky. Okay, in the when they are saturated. So because they become sticky, when these piles were tested for uplift means you try to pull them out, you try to pull out these piles. Now tell me, I know that you don't know the basics of pile right now, we would be discussing it during our course, but just on the basis of common sense, tell me that if I try to conduct an uplift test on my piles just after the monsoon, when the groundwater table is very high and the soil is very sticky, what do you think will happen? What do you think will happen? You will get a good uplift capacity. Do we agree or not? I will again repeat my statement. What I am saying, that we decided to test this pile through initial test, what we call it as. So these tests were conducted just after the monsoon. Your groundwater table was very high. Okay, so your clayey soils were very sticky. They were sticking very properly to your surface of the pile. So what do you think your uplift capacities would be, higher or lower? What would be the uplift load in this case when you do testing in rainy season or just post monsoon? What do you think? So actually you will get a good uplift capacity, isn't it? You will get a good uplift capacity. Why? Because I will explain you these things later. Because skin friction between soil skin friction between this soil and the material of pile or concrete is very high. So because of this, you will get a very good uplift capacity. Are you getting this point? Yes, no? Hello? Okay. So everyone was very happy. Everyone was very happy that their test piles that they tested, they were matching with the field. They were matching with the theoretical pile capacity. Everything was going very good. All right. Then what happened? Then they started their construction. So they started their construction. They had to cast piles. So then they cast some, I think 500 or 600 piles were cast. And then your code tells that you have to also test your piles that are going to be part of your project. So let us say this was the test pile right now, which you were just using for testing purposes. This pile is your project pile. What is meaning of project pile? This pile is going to become the part of your project. Okay. So on these project piles also, you need to carry out certain testings, which are called as routine tests. I will tell you all these names in the code. These are called as routine test. So this you have to carry out on your project piles. Now they started these routine tests after I think 500 or 600 piles. Out of this total 6,000 piles were cast, and they started doing their routine tests. And to their horror, in their routine tests that they conducted, they noticed that their uplift capacities coming were very low. Uplift capacity was very low that they tested, very low as compared to these test results that they had got from their initial test results. So what had happened was that these routine tests they were carrying out on their actual project piles, they were carrying out this test I think in the month of March or April. These routine tests were being carried out in the month of March or April. So what happened? So in these months, what happened actually that your groundwater table went below, your groundwater table receded. Okay. Now, because your groundwater table went below, your soil became dry. And because this was a clayey type of soil, what happened was that your soil, the skin friction between soil and the pile material reduced. Because of this lower skin friction in dry condition, the uplift capacity that came out was extremely low. Is it clear? Do we understand this problem? This is just the opposite of what we discussed in the second case, isn't it? This is the exact opposite of what we discussed in the earlier case. So therefore, your soil, which was moist in the rainy season, which gave you good results against uplift, it became dry. And because it became dry, there was shrinkage that was observed in your soil. And because of that shrinkage, it gave a very, very low uplift capacity. So there was a big issue. I mean, this was a big shock to everyone involved in the project. And then 600, imagine 600 piles were already cast. And when they did their routine test, they were faced with this surprise. So in this case, they didn't have any other option left. They had to increase the self weight over here. They had to increase the self weight over here just to add to the uplift capacity. Okay. And for the other piles that were not casted, they had to increase the length of the pile. So that was the remedial measure that was taken. All right. So this was the third case that I wanted to tell you. Are we clear? So in the second case, moisture was a villain for us. In the second case, moisture was a villain. In this third case, moisture was actually a good thing for us, isn't it? Anyway, is this third case clear? Yes or no? Yes. Any questions till this point? Any questions till this point? Yes, no? Okay, I hope there are no questions. All right. Then we will come to, or we will discuss another case. So this we were, uh, yeah. So what did we, how were we involved in this case number 3? We were involved in this case number 3 as I told you, design reviewers. So we were from the very beginning suggesting them that this 1.5 meter pile will not be proper against uplifts. Okay. But then in their initial tests that they carried out, they got good results. But then everyone was left to a shock after routine tests when they saw that there was a very low uplift capacity. So what was the solution, or what was the remedial measure given by us? So to increase the uplift capacity, we decided to increase the weight. So this self weight was going to add to the uplift resistance of my pile. So in those piles which are already cast, we suggested them to go for a very thick pile cap to add to the uplift. And for the piles that were not cast, I told you only 600 piles were cast. Rest 90% of piles were not cast. So in those piles, we decided to go for longer length of my pile. Okay. Okay. Another case I will tell you. Here we were involved as design reviewers. No, sorry, we were the structural designers for this project. There were no surprises in this project. I just want to tell you the difficulties that we may face. So this was a industrial complex that we were doing in Bengal. Okay. Now in Bengal, or in the entire northern plains, if you see, there is a thick alluvial soil bed that you get, isn't it? Because of years, millions of years of alluvial soil that is being carried by the rivers, Ganga, Yamuna, countless rivers that you have. What you get is thick alluvial bed. Those alluvial beds do not give you proper bearing capacities. So those alluvial beds will give you only around 8 to 10 kilonewton per square meter bearing capacity, which is very low. Okay. So we had to make an industrial complex, large industrial complex actually. So in these large industrial complex, and this was in a zone in Bengal, which is under cyclonic zones these days. So we had to design for large wind pressures also. So when the testing was done, proper testing was done. So there were no surprises in this case. I'm just telling you the site conditions, how they vary. So we got 28 meters, not feet, 28 meters of alluvial bed. Imagine. So 28 meters of alluvial bed, 28 meters length, where you could not provide any isolated footings because you would get a very low bearing capacity. So the only option that we were left with was to provide piles. So we had to provide piles, I think 30 to 35 meter in length. Still we could not reach hard rock. We had to provide them in the alluvial bed itself. But because of this large length, because of the large skin friction that we could get, we were able to achieve the required uplift and compression capacities. Okay. So imagine 30-35 meters of your pile we had to provide for these industrial complex. Okay. There was no surprise. I'm just telling you that this type of design also you may have to carry out. So all these were done by proper geotechnical investigations, and that's how they gave us the recommendation for piles. They also gave us the suggested capacity for piles, and that's how we did the design. For smaller structures in this same project, as I told you, this was an industrial complex having many structures. So for smaller structures, we provided isolated footings. In some structures, we also provided rafts, but only for the main shed. This shed was also a big shed. It was, I think, around 35-40 meter span. So for the shed itself, we had to provide piles, deep piles. Okay, piles going till 30-35 meter depth. Huge. All right. No surprises for this project. I'm just saying that this is also what you can get. Okay. Then I will tell you another project, which was an institutional building, reputed institutional building in Indore. Again, we were involved at a later stage as designers for the road infrastructure in this campus. Now, what they had done is, this is a general case I'm discussing. It has got nothing much with the geotechnical investigation as such, but just a normal case I wanted to discuss. So the campus terrain that they had got was hilly terrain. Okay, not so much undulations, but you had got good amount of undulations in this project. Now, typically, it is always recommended to respect the natural terrains. So what that means is that if you have this kind of a topography, you should always try to respect the natural terrains, and you should try to construct your buildings as per the terrains itself. That makes everything very simple. That makes your life very simple. That makes the planning for all other services also very simple. That is the usual rule that we should follow, to respect the natural topography of your ground. But what they decided to do was, instead of following the natural topography, they decided to level this out. Okay, so they decided to level this out by cutting and filling. So they decided certain levels. So this entire level, this entire mass, huge amount of excavation or huge amount of cutting down was required. Okay, so this orange line is the level that they decided, and because of this, huge amounts of cutting and huge amounts of filling. So huge amounts of filling were required over here. Okay, so what did we finally have? We had this level. Now, because they had cut down hard rocks, there was a mountainous terrain. So there was a hard rock that you were having over here. Okay, so because of this hard rock strata, they had already reached hard rock over here, very, very hard rock, which sometimes could not even be broken by your hammers or by your backhoes. So you had to sometimes go for blasting also. Okay, so in this case, what they had to do, they had to provide roads over here. Now here they had to provide a road. Now the road itself requires certain thicknesses, and the road itself requires some depth and some layers, as you know. Now what they had to do, they had to further drill, they had to further blast actually another 600 to 800 mm of hard rock just to accommodate this road. So why all these things happened? Because this big institutional building, whoever was doing the master planning, they decided not to respect the terrain. So because they did not respect the terrain, they had to incur such heavy costs, and then they had to unnecessarily go for blasting, drilling, all those things. So it is always suggested that whatever is the natural topography of your site, you should always try to respect that. Otherwise, it leads to problem later on. Till now, they are facing this problem, that because they have disturbed the complete topography of this site, they always face the problems of water stagnations. They are always not able to, they have not been able to provide proper service lines. So there is always a big problem. Their sewage system these days is not able to work on gravity. So they have to install pumps to pump their sewage to treatment plants. There are lots of issues. So all those issues because they decided not to respect their terrain. So this is not directly related to ground geotechnical investigations, but I just wanted to tell you that as structural engineers, if at all you are going to be involved in planning level, you should always try to tell the master planner to be respectful of the natural terrain. Okay. So these were some cases that I wanted to discuss. I think these cases sufficiently uh, emphasize this point, that why geotechnical investigations are important and what are the problems you would face if proper investigations are not carried out. I hope we are clear with all these cases. Hello. I'm sure as practicing engineers, as working professionals, those of who are involved as working professionals, you might have faced many more such examples in your work life, isn't it? Which would emphasize this point, that why geotechnical investigations are important. Yes, there are few questions I'll just take up. Mr. Vikram is asking, can we provide a filter media all around the basement to drop the capillary action of groundwater? But see, then those filters have to be really very, very fine, isn't it? Because water just needs a very, very thin capillary to just, I mean, water needs a very small space to pass through, isn't it? So I don't know whether how much effective that filter media would be. Mr. Atif is asking, but in such undulated terrain, usually ground is leveled with cutting and filling, because without that construction would be, construction would be more difficult. I agree. But finally, it leads to a lot of, I would say it leads to a lot of saving in other issues. It is, see, this cutting and filling is good for road projects. Let us say you have a road project. This cutting and filling is good because what happens, that the cost that you spend in your cutting, isn't it? Let us say this is your this thing. The cost that you spend in cutting is offset by the cost that you save in filling. So generally in road projects, you will see that you try to manage cutting almost equal to filling for optimization, isn't it? But this was actually an institutional building where a lot of things were interconnected. So your service lines were interconnected, your water supply schemes were interconnected with each other. So because they decided not to properly follow the contour, because they disturbed the gravity, I would say because they disturbed the local topography, none of their service lines could perform under gravity. Okay. So what happened? Because they had done so much heavy cutting, and because they had converted everything at a planar level like this, then when they were asked to provide lines, service lines, let us say this was a sewerage line. Now, generally, the sewerage line flows under gravity, isn't it? Now, because they had cut so much, now further cutting meant that they had to do a lot of blasting, because already they had cut 6, 7, 8 meters. Now, once you have cut this much, you naturally encounter very, very hard strata, which could not be cut with drills, which could not be cut with hammers. You just had to use blasting for this. So just to provide their service lines, sewerage lines, water supply lines, which all function under gravity generally, they had to further go for much more blasting and much more cutting, isn't it? And to this day, these schemes are not working under gravity as well. So they have to install pressure pumps. I think at 4 or 5 locations, they have installed pressure pumps because gravity systems are not working. So these pressure pumps basically push the sewerage, and they get a lot of chokes because these pressure pumps also not work sometimes. They have to do manual lifting of sewerage. There are lots of issues. Okay. So if they would have followed the contours properly, if they would have respected the terrain properly, all these things would have worked well under gravity systems. Understood? So what you are saying, construction would be difficult, I agree. But when you have got such buildings, institutional buildings, which are interconnected, there are a lot of services that are interconnected. then you should try to respect the levels. If you are going for a standalone road project, okay, if you are going for a standalone road project, then it is okay that you try to maintain a level ground, because you also have to look at the driver comfort, isn't it? And you also have to look into the cutting filling cost. And road is an independent project, it is not connected with other structures as such. All right, so uh, we have tried to take certain cases which will emphasize this point, that why carrying out proper geotechnical investigations are extremely important for your project. All right, just hold on. Yes, just give me a minute, I will be back. I'm just putting my video and audio on mute, I'll be back, just a minute. Okay. Yes, am I audible again? Hello, am I audible? Yes, yes. Okay. So I think we have discussed quite enough, and you have understood the importance of geotechnical investigations. Remember, we are not expert geotechnical people. Okay, we are not trying to become experts in geotechnical studies. If we become, it is well and good. But right now, our emphasis is on the structural design and detailing of foundations. But still, because geotechnical investigation is an important aspect of this, we are discussing it over here. All right. Just hold on again. Okay. All right. So next point. So then what is the objective of our geotechnical investigation? Okay. Why do we want to carry out geotechnical testing? So there are a few reasons why we need to, or objectives that we have in our mind when we want to do any geotechnical testing. All right. So these are the objectives. I think we are running short of time today. All right. It is already 10 to. So what I will do is we will start with this from tomorrow. All right. So tomorrow we will start So we have understood, see what we have understood right now. We have understood why geotechnical testing is required. We have understood it through 5-6 cases that we took. Why geotechnical testing is required, that we have understood. Now, when we go to site to perform geotechnical investigations, what are our aims and objectives? What is that we want to achieve through these geotechnical investigations? That we will start from tomorrow. Okay. So the aims and objective we will see tomorrow. Today we have tried to understand why investigation needs to be carried out. And then once we have understood why these investigations need to be carried out, we will now understand from tomorrow that what is the aim and objective, or what are our goals that we are looking at. So all these are the points. I will like to discuss it one by one. We'll start it tomorrow. It would be better. Okay. All right. So are there any questions? Today is the first session, so we are wrapping it up slightly early. Are there any questions? Yes, before we take on Q&A, just a few instructions to all of you. So many of you are seeing sessions live, and many of you are going to see sessions on the portal later on. So all of you have been added on the portal. You must have received mails in the inbox, your mail inbox. What we will do is that we will send you detailed instructions. We will send you detailed instructions to access the sessions on the portal. All right. Those who are joining the courses in Oxen for the first time, they will have to follow those detailed instructions which we would be sending you in the group shortly. Those who are already part of earlier courses with Oxen, they will automatically find this new course uploaded on their portal. Okay, we will share the instructions to be followed. All right. Now there are a few questions. I'll just take them quickly. Mr. Atif is asking, geotechnical investigation should be carried out in which period? Pre-monsoon, monsoon, or post-monsoon ideally? See, now this may not be in our hands, because many times there is a urgency to start your project. So as a client, let us say you want to start it in May. Okay, you cannot wait for 3 months, isn't it? Or let us say if you are in October, you cannot wait for post monsoon next year. So generally these times are not in our hands. These time periods may not be in our hand. So what you can do is, as experienced geotechnical engineer or as experienced structural engineer, what you should do is that in whichever season you are carrying out your investigation, you should take into account adequate corrections. Are you getting this? You should take into account adequate corrections. For example, as I just explained, you did your geotechnical investigation in summer months. So you should take into account adequate corrections for groundwater table. Or let us say you carried out geotechnical investigation in post monsoon, you should take similar corrections. Is it clear? So there cannot be an ideal season as such, because it all depends on the client and their urgency for the project. You cannot wait for 2-3 months for the ideal period. So what I would suggest, you take adequate corrections into your account. Clear? All right. Then the second question being asked by Prasad sir, generally what type of measures need to be considered in black cotton soil for shallow foundations? Yes, in shallow foundations, ideally you should remove the black cotton soil. All right. For example, let us say this is your ground level, and let us say you have 2 to 2.5 meters of ground black cotton soil. So ideally you should remove all the black cotton soil. That is the most ideal situation. Okay. So generally in Indore, you will always see that we will remove the black cotton soil layer. This is possible for buildings. This is possible for buildings. Removal of 2.5 meters of black cotton soil is not that bad, because this soil is actually very good for agriculture. So then this soil is sold to landscape people, those who are going to develop some landscape, or those who are going to develop some gardens, etc. This goes for a very good price actually. Okay. So removal of black cotton soil is a good option for buildings. But let us say if you are going with some infrastructural project, let us say you are going for a road project. Now in road project, removal of 3 meter of black cotton soil is not possible. So in those cases, what you need to do is, or what we generally recommend is, let us say this is a road project, this is a road. So this is road. Now for road, you cannot expect removal of 3 meter of black cotton soil. It would be too costly. So what we do is we remove around 800 mm, 600 to 800 mm of top black cotton soil layer. So what we would do, we would remove some 600 to 800 mm of black cotton soil layer. Why this 600 to 800 mm layer? Because this is where your moisture movement takes place. Moisture movement means shrinkage and swelling is most seen in this top 600 to 800 mm layer. So you remove this layer and then you do stabilization of this soil. So this soil you stabilize typically by some lime solution. So what do we do is we put some lime solution, lime plus water. We put this lime water solution and we just fill this layer. Sort of for dosage, we give this dosage to our top soil after 800 mm layer removal. So this soil gets stabilized to a certain extent, and then you can put your compacted whatever you have to put. Let us say you have to put a sub base, whatever you want to put, and that's how you can do your road level. That is the second option. If you are going for a building, first recommendation would be to remove the black cotton soil layer as far as possible, because remember that, let us say when you are going to put some ground slab over here, even these ground slabs will be facing the problem of swelling, isn't it? So soil removal is a good option. Prasad sir is asking plum concrete is good option or soil replacement. See, plum concrete again, how much plum concrete you will do, isn't it? You cannot do a 600, 800 mm plum concrete. That is too costly. So soil removal, soil stabilization to a certain extent, and replacing it with some muram is cheaper than filling it with plum concrete. Yes. Any other question? Any other question? Doubt? All right. So then we stop over here today, slightly early. But because today was the first session. So tomorrow when we meet, what we are going to start our discussion with, we are going to start our discussion with what exactly do we need to achieve by doing the geotechnical investigations. What are our objectives? What is the aim? And what are the goals of carrying out a geotechnical investigation? So that is what we are going to study tomorrow. Today we have tried to understand what is the need of carrying out investigations and what are the actual problems that you may face if improper investigations are done on site. So that is all from my side. We will share the instructions to watch the videos on the portal. That is all what I have. Thank you and have a good day. We'll see you tomorrow at 8:30. Yes. Bye bye. Thank you.